Hello everyone, I'm Hasree from class 10th and today I'm going to explain a small topic from the chapter electricity, that is electric power. Firstly, let's quickly recap what we know about power. What is the definition of power? The rate of doing work is called power. That is, in the form of an expression, we can write power like this. Power is equal to work by time or energy by time. Now, let's see what is electric power. We know that when an electric current flows through a conductor, electrical work is being done. Also, the electrical charges consume an equal amount of electrical energy. On that basis, we can frame the definition of electric power like this. Electric power can be defined as the electric work done per unit time. That is, electric power is equal to work done by time taken. Electric power can also be defined the other way around. We know that any work done consumes an equal amount of energy. So, electric work can also be defined as the electrical energy consumed in unit time. That is, electrical power is equal to energy consumed by time taken. Now, let us see the SI unit of power. The SI unit of power is watt, named in honor of the scientist James Watt. How to define watt? It's simple. We know the formula power is equal to work by time. Now, substituting the SI units of power, work and time in this formula, we get watt is equal to joule by second. That is, 1 watt is equal to 1 joule by 1 second. So, watt can be defined like this. If 1 joule of work is done in 1 second, then the power is said to be 1 watt. Now, how to calculate electric power? Well, we have many formulae for doing that. Let's see some of them. The first formula, as we've already seen before, is power is equal to work by time. That is, P is equal to W by T. Another formula to calculate electric power is P is equal to VI. Another formula is P is equal to V squared by R. And the other formula we have is P is equal to I squared R. Now, let us solve some problems based on what we have learned. The first problem which we have is shown here. Calculate the current drawn by an electric bulb of 40 watts when it is connected to a source of 220 volts. In this question, we've been given power and potential difference. That is, power is equal to 40 watts and potential difference is equal to 220 volts. And we've been asked to calculate the electric current, that is I. Now, we know the formula P is equal to VI. From this formula, we get I is equal to P by V. We know the values of P and V. So, by substituting those values in this formula, we get I is equal to 40 by 220, which is equal to 0.18 ampere. So, the electric current drawn by the electric bulb of 40 watts when it is connected to a source of 220 volts is 0.18 ampere. Now, let's see another problem based on electric power. If two bulbs, one rated 100 watts at 220 volts and the other 60 watts at 220 volts are connected in parallel to the electric mains supply, find the total effective resistance. In this question, we have been given two bulbs, bulb 1 and bulb 2. Bulb 1 is rated 100 watt at 220 volts. That is, for bulb 1, potential difference is equal to 220 volts and power is equal to 100 watts. Bulb 2 is rated 60 watts at 220 volts. That is, for bulb 2, potential difference is equal to 220 volts and power is equal to 60 watts. We have been asked to find the total effective resistance when these two bulbs are connected in parallel combination. To find that, firstly, we need to find the individual resistances of both the bulbs separately. That is, we need to find the R value of both the bulbs. To find that, we have a formula called P is equal to V squared by R. From this formula, we can get R is equal to V squared by P. Now, we know the values of V and P. Substituting these values, we can get the resistance of both the bulbs. Let us see it one by one. Firstly, for bulb 1, we have the formula R is equal to V square by P, and we know that V is equal to 220 volts and P is equal to 100 watts. Now substituting these values, I get R is equal to 220 squared, which is nothing but 220 into 220 by 100, which when simplified gives R is equal to 484 ohms. So for bulb 1, the resistance is 484 ohms. Similarly, let us calculate the resistance of bulb 2. For bulb 2, also we use the same formula R is equal to V squared by P. We know that V is equal to 220 volts and power is equal to 60 watts. Substituting these values, we get R is equal to 220 squared, that is 220 into 220 by 60, which when simplified gives R is equal to 2420 by 3 ohms. Now we got the individual resistance of both these bulbs, but we have been given that these two bulbs are connected in parallel combination and they're asked to find the effective resistance. We know the formula of finding the effective resistance when two resistors are connected in parallel combination. That is, 1 by Rp is equal to 1 by R1 plus 1 by R2. Here R1 is 484 ohms and R2 is 2420 by 3 ohms. Substituting these values, we have 1 by R1 is equal to 1 by 484 and 1 by R2 is the reciprocal, that is 3 by 2420 ohms, which when simplified gives 2 by 605 ohms. But this is the value of 1 by Rp and we are asked to find the value of Rp. How to find it? It's simple. Just take the reciprocal of 2 by 605. So Rp is equal to 605 by 2, which gives 302.5 ohms. That means the total effective resistance when these two bulbs are connected in parallel combination is 302.5 ohms. I think we have learned enough about electric power. And here ends my explanation. Thank you.